Azure Monitor offers Microsoft customers a best-in-class observability solution for cloud and edge. The Azure Monitor product is built around 4 key tenets. Number 1, monitoring is just there and works across Azure and edge. Whether you are running your workloads in the Azure cloud or in edge environments, Azure Monitor is available to provide customers with consistent experiences and reliable insights. Number 2, ability to observe at any level and across the stack. Issues can occur anywhere, so customers need visibility across the stack. Be it infrastructure, networks, or applications, Azure Monitor offers a comprehensive monitoring capability for every layer. Number 3, open and extensible platform for innovation. Azure Monitor provides APIs for all capabilities and exporters for all data. Azure Monitor also has robust support for automation and infrastructure as code workflows. This gives customers great flexibility in adapting Azure Monitor to their needs. Finally, number 4, enterprise ready for mission-critical scenarios. Azure Monitor is built with high resiliency, scalability, and security in mind. Enterprises can trust Azure Monitor to run their mission-critical workloads. With tools like proactive alerts, Azure Monitor helps customers operate even their most complex and sensitive systems with uninterrupted continuity. So what are some of the observability scenarios that Azure Monitor can tackle? First off, you can detect and diagnose issues across apps and their dependencies with Application Insights, our powerful APM solution. You can correlate issues at the infra level with insights for VMs, containers, SQL, networks, and more. You can operationalize at scale with smart alerts and automated actions. You can drill down with log analytics for troubleshooting and deeper diagnostics. Finally, you can create visualizations with Azure dashboards, workbooks, and Grafana. Azure Monitor provides tooling for the entire journey, spanning data collection, storage, visualization, alerting, and remediation. So how does Azure Monitor work? It all starts with collecting telemetry. Azure Monitor can collect data from applications, networks, infrastructure. You can also ingest your own custom data. All the data is stored in centralized, fully managed logs and metric stores. So what can you do without the data? Typically, you start with insights, which are our end-to-end experiences put together for canonical scenarios and resources such as applications, containers, VMs, networks, storage, etc. Insights provide troubleshooting guidance and help detect root causes quickly with a drill-down experience. You may, in certain cases, just want to visualize data. For that, we provide Azure dashboards, Power BI integrations, and a more native experience called workbooks. After visualizing the data, we may form some hypotheses and want to test them out. For that, you need access to raw data stores. You can access raw data using Metric Explorer and a powerful big data platform called Log Analytics. Log Analytics is capable of querying petabytes of data within seconds. If you want to be proactive and take corrective actions, you can create alerts and runbooks to auto-remedy an issue. For capacity issues, you can also scale up or scale down automatically. Finally, we know that monitoring isn't done in silos. Azure Monitor provides out-of-the-box integrations with popular ITSM and DevOps tools. You can use APIs, Event Hub, and Logic Apps to build custom integrations. When customers create AKS clusters, they can choose from a variety of cluster presets. With the new Monitoring tab in AKS, your clusters now come with out-of-the-box monitoring. We have carefully selected presets that are designed to match your user needs, from production standard to production economy to production enterprise. Now with Azure Monitor, you get container logs, managed Prometheus, and managed Grafana dashboarding with a simple click. The container log v2 schema, which replaces the container log table, offers streamlined querying and reduced query complexity. It supports multi-line logging, allowing to consolidate entries when dealing with multi-line output. Additionally, we are introducing a new Kubernetes logs metadata feature, which includes essential metadata such as container name, pod label, pod annotations, and pod namespace. With this feature, you can efficiently analyze container logs, categorize them by log level, leverage annotation-based logs filtering, and benefit from enhanced performance. Customers can access the Kubernetes metadata feature through the command line. Simply apply the config map to your cluster and you are ready to go. Let's see how customers can access this Kubernetes metadata. Here, I have queried the container log v2 table. On expanding the rows, I see a new Kubernetes metadata field. On expanding the field further, I can see all the metadata that has been passed down into my logs. This looks like rich user information. That's it. Now I can combine metadata with the full power of log analytics to perform rich analysis. By attaching key value pairs to resources such as pods, services, and more, DevOps engineers can gain superpowers. These labels allow for grouping based on criteria such as application, environment, team, and more, enabling customers to streamline troubleshooting and analysis. Networks are some of the hardest areas to debug for Kubernetes customers. The new network monitoring add-on gives you detailed networking metrics. Customers get packet drops, DNS queries, and more to trace the root cause of issues in their network. The network monitoring add-on can be enabled with a single command. Just toggle the Enable Network Observability flag for your cluster and you are done. The network monitoring add-on is integrated out of box with Azure Monitor. Once you enable the add-on, metrics are automatically ingested into our Managed Prometheus service and are visualized in out-of-box dashboards in Azure Managed Grafana. The latest release of the network monitoring add-on brings you an advanced metrics offering with pod level metrics for everything from flows to drops as well as DNS metrics. Azure Monitor is releasing an easy way to onboard to App Insights for your applications running on AKS. Auto instrumentation enables you to onboard to application monitoring without changing any code or configuration. By following these simple steps, you can onboard quickly and easily access your telemetry like application level logs, metrics, traces, and more available in your Application Insights resource. Stay tuned, a portal-based experience to onboard to App Insights using auto instrumentation is coming soon. Container Insights previously used data from log analytics to power visualizations in the Azure portal. However, with the release of Managed Prometheus, this new format of metrics collection is cheaper and more efficient. Container Insights now offers the ability to visualize only Managed Prometheus data. We will show you how you can use Managed Prometheus as your primary Container Insights visualization tool. Because my cluster already has Prometheus enabled, I can simply use the top toolbar to change to Visualize with Prometheus. Now all my charts are powered by Managed Prometheus data. Additionally, customers can save costs by disabling the log analytics tables they no longer need. For example, customers can switch from the standard preset to the logs and events preset. You don't need to stop there. Now, you can also visualize your Prometheus data using the query editor. This tool acts as a gateway to leveraging PromQL queries for your Prometheus metrics within the Azure portal. Before this, your primary way to visualize Prometheus metrics sent to an Azure Monitor workspace was in Grafana. Unfortunately, this meant you couldn't query your Prom metrics from within the Azure portal at all. This restriction led to frustration due to fragmented experiences and extra steps while troubleshooting. With the query editor's integration of PromQL, customers can now access advanced querying capabilities within the Azure Monitor Metrics Explorer. No longer do you need to leave the Azure environment. You can handle all experiences in one place. This feature is readily available within your Azure Monitor Metrics workspace. Simply navigate to your Azure Monitor workspace, click on Metrics under Monitoring, and start crafting your PromQL queries. Here, I'm trying to visualize the memory for the pet clinic container. Looks like it's stable. Give it a try today. To ensure that your infrastructure is resilient, it is very important to enable recommended alerts. Azure Monitor provides a set of recommended alerts which you can enable with one click. This also includes Prometheus community alerts. For cloud-native Kubernetes monitoring, Grafana is the de facto standard for visualization with its rich community of dashboards. Azure Monitor natively integrates with Azure Managed Grafana for AKS and provides out-of-box dashboards for monitoring and troubleshooting. On screen, you can see our full stack AKS dashboard. And here is our new network observability dashboard to monitor your Kubernetes cluster network. Once you've onboarded to application monitoring using auto instrumentation, you unlock a myriad of application monitoring experiences. You can begin your journey with the application map, which provides a visual overview of your application and its components. Beyond the application layer, you can also gain an insight into infrastructure health within the app map, providing you full stack observability. App Insights offers curated experiences such as performance and failures, enabling you to identify performance bottlenecks in your application. Users can drill to a trace level view using distributed tracing experiences like end-to-end transactions. This is just a glimpse of the various offerings available, including live metrics, availability, profiler, and more. Please visit the App Insights documentation to dive in further. Now let's talk about logs management. Let's talk about what's new with log analytics. First up, we have new retention settings in log analytics. Log analytics allows you to get the right flexibility to match your business needs. Data that was ingested as analytics logs can be retained at that tier for up to 2 years. In that period, there is no limit to the queries you can run, and you can use the full power of analytics queries. Customers use this option for frequently used data that is queried all the time. After an initial retention as analytics logs, you can archive them as auxiliary logs for up to 12 years in total. This option is much cheaper, but has limits. Data access needs you to run a search job, which has a cost. Most customers are using auxiliary logs for data that is rarely used. Examples being data stored for compliance reasons or data that is saved just in case. Since log analytics is a managed service, you don't need to do anything to implement these retention settings. Just tell the service what you want to do, and the service will take care of data management and will adjust itself accordingly. Next up, we have a powerful new feature, attribute-based access control in log analytics. Many organizations feel the need to segregate and control access to data in a fine-grained manner, while also maintaining a centralized and consolidated logging platform. On top of the existing capabilities of workspace and table access, you can now maintain all your data in a single log analytics workspace and provide least privilege access at any level using Azure role and attribute-based access control. For example, you may want to provide access to your sign-in logs so that users will only be able to view data associated with their geographical location. Using attribute-based access control, you can select the tables and rows accessed by a user based on your business and security needs. You can restrict users' access based on characteristics such as organizational roles, units, locations, data sensitivity levels, and more. Relatedly, Azure Policy is an extremely powerful tool for governing and automating parts of your Azure environment. It can turn repetitive and time-consuming processes like manually setting up audit logging for thousands of Azure resources into a painless automated process that ensures any future resources you deploy are automatically set up without the risk of manual error on the way. In 2023, the Azure Monitor team shipped 3 Azure Policy initiatives for enabling audit logging at scale. These initiatives span 33 different resource types. The Azure Monitor team has prepared a large update to these initiatives, expanding them to support a majority of audit-supported resource types and encompassing over 60 total resource types. In addition, we have also released 3 brand new policy initiatives for enabling every logging category for selected resource types at scale. This new initiative encompasses over 130 different resource types, and it will allow you to enable logging at scale to log analytics, storage accounts, or event hubs with a single policy initiative assignment. These policy initiatives are now available to Azure customers. For Azure Landing Zone customers, be assured that a release is imminent to accommodate these updates. Now let us walk through a troubleshooting scenario where Julia, a DevOps engineer, gets an alert that pod memory has exceeded 95% for the pet clinic pod. Now she needs to quickly investigate and identify the root cause. Julia starts her investigation journey in the AKS portal. She first navigates to the workload section, and then moves to the pods tab. Here they can observe the memory and CPU of all pods in the cluster. Sorting by memory, they see that the memory for the pet clinic pod is the highest. She then double-clicks the pet clinic pod to look at the Metrics Explorer chart. The query editor in Azure Monitor is in public preview and open to all. They can select any metric they want. For this example, let us plot the container working set memory metric. For this example, I have pre-filled the queries in the editor. To analyze memory consumption, I have plotted 3 metrics for the pet clinic pod. Number 1, its memory request, the lower pink line. Second, its current memory consumption, the blue line. And finally, its memory limit, the upper green line. As we can clearly see, the pet clinic pod's memory consumption is very close to its limit, and there are memory consumption spikes where it was nearly reached. Thus, with a few quick queries, you can quickly plot metrics right here in the portal and analyze the behavior of your workloads. We just saw how a DevOps engineer can use the query editor to swiftly diagnose the issue by crafting different PromQL queries with just a few clicks. With the query editor's interface, a DevOps engineer can easily explore various metrics related to their AKS plot clusters' memory usage. By composing different queries, they can compare current memory with historical data, identify trends, and visualize the data. Try out the public preview query editor for your troubleshooting needs. To investigate further, Julia goes to Insights and sees that the pod memory consumption is extremely high. She navigates to Log Analytics to investigate further. Today, we are announcing public preview of a new logs consumption experience. Number 1 is Simple Mode. Simple Mode offers the most commonly used log analytics functionality in an intuitive spreadsheet-like experience, requiring no KQL knowledge at all. Just point and click to filter, sort, and aggregate data to get the insights you need most of the time. KQL mode gives advanced users the full power of Kusto query language to derive deeper insights. Julia uses the new Simple mode for Container Log V2 table filters. Here she sees the errors for her pod name 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 logs. Expanding on the log message, we see recurring out-of-memory errors, confirming that the pod is getting 𝗬𝗲𝗀𝗀𝗀𝗀. To further identify the root cause, Julia moves back to Insights and inspects the pod details. Here she can see that the pod is getting killed because of very low limits and requests that have been set up. She goes on to update the pod YAML to ensure her application has enough memory to sustain the workload. Julia can also complete this journey in Grafana. Azure Monitor provides a variety of dashboards out of the box. Example, here is a full stack dashboard for AKS. Today, we're thrilled to announce Kubernetes Logs Metadata, a brand new dashboard designed specifically for logs consumption in Grafana. This dashboard not only allows you to troubleshoot logs and metrics within the same intuitive experience, but also supports filtering by Kubernetes metadata such as labels. You can leverage essential metadata like container name, pod label, annotations, and more to efficiently narrow down your logs. Starting at the top, we have color-coded visualizations of log counts by log levels, ranging from critical to unknown. This dashboard also automatically defines log levels for better data categorization. The log level is deduced through keyword matching from the log message. Users can drill down even further. Clicking on any panel brings us two options: View in Azure Portal or Critical Explorer. View in Azure Portal takes you to the Azure Portal and shows the logs behind this query. Similarly, Critical Explorer opens up Explorer view in Grafana. If we scroll down, we have sections for log volume, log rate, log records, and finally, raw logs, which customers can use to get a sense of system behavior. In the logs table experience, not only can customers see details, but clicking on the View in Azure Portal takes you to the source of the logs, executing the exact query. Let us look at a second troubleshooting scenario. Here, John, an application developer, gets a ticket that his application is running slow and is facing intermittent crashes. They start their troubleshooting journey from Application Insights, or the app layer. They use App Insights to analyze the telemetry of the application that is of concern. They land on the application map, which gives them a visual overview of the application architecture, components, and interactions. Here they spot some failures on the pet clinic microservice. The red on the node indicates that there have been failures on this app. The developer has a hypothesis that this might be the performance bottleneck or the failure hotspot. They click on the pet clinic service, and on the right, they can see their slowest requests, their top failing requests, amongst other things. Also, they get a high-level overview of infrastructure health: CPU, memory, pods, restarts, etc. They can choose to navigate to the infrastructure layer in case they see something out of place in these metrics. For this, the user chooses to investigate failures, as there are some high numbers of failures in the application. Upon landing on the failures page, they can see a high number of out-of-memory errors and runtime exceptions. The user clicks on the out-of-memory exception to see an associated trace. They see multiple trace samples on the right. When they click on one of the trace samples, they land on the end-to-end transaction page that shows them the trace view. In this trace view, the user can clearly see which operation and service is the culprit that is causing the app to crash. Clearly, there is a Java out-of-memory exception that is causing the application to run slow. The user can see which method is failing and which exception type has occurred. They also have details like the pod name, namespace, and container in which this app is running. They can now assign it to the concerned developer to fix the issue. On the other hand, if the user had a hypothesis that this is an issue on the infrastructure side, they can now investigate the infrastructure layer through the Container Insights module. They can see infrastructure metrics associated with a given service, which includes fail pod, CPU usage, memory, and more. By clicking on Investigate Pods, they will land in Container Insights, where they can see the health of pods, controllers, or clusters. If they see something wrong in these metrics, they can investigate. On clicking Investigate Pods, the customer will land in Container Insights and see the exact controller and pods that are associated with their application. After landing in Container Insights, the customer can see the overview of their controller. They can see live events if they choose to. They can click on the associated pod and see pod details. These include container limits and requests. They also have the option to see what are the associated application level metrics for the pods. What are the different operations they're running and what are the failure counts. If there is something out of place, customers can easily navigate from here back to Application Insights. And if an issue is confirmed on the app layer, they can assign it to the developer to fix it. In summation, these are correlated full-stack observability experiences that users get out of the box in Azure Monitor, and these will help them drastically reduce their mean time to resolution. Before moving to what's new in Edge Observability, let's recap our end-to-end Azure Monitor pipeline flow. Azure Monitor pipeline is part of an ETL-like data collection process that improves on legacy data collection methods for Azure Monitor. This process uses a common data ingestion pipeline for all data sources and a standard method of configuration that's more manageable and scalable than others. You may have various resources or applications running on Azure or on-prem. Typically, the telemetry is collected using our agents and sent to Azure Monitor. All data is processed through the cloud pipeline, which is automatically available in your subscription and needs no configuration. Each collection scenario is configured in a data collection rule, which is a set of instructions describing details such as the schema of the incoming data, a transformation to optionally modify the data, and the destination where the data should be sent. However, some environments may be more restricted, so we are now extending our Azure Monitor pipeline capabilities to the edge environments, as well as to enable customers to route high volumes of data from edge to cloud. Azure Monitor Pipeline for Edge is a powerful solution designed to facilitate high-scale data ingestion and routing from edge environments to seamlessly enable observability across cloud, edge, and multi-cloud. It leverages Open Telemetry collector as its foundation. It provides high-scale data ingestion. Customers have many IT/OT devices and resources that emit high volumes of data and need to be routed to Azure Monitor. With Azure Monitor Pipeline, they can seamlessly ingest high-scale data by running multiple replica sets of the Azure Monitor pipeline at the edge and scale horizontally to route high volume of telemetry to Azure Monitor. Number 2, reliable data ingestion to prevent data loss. Edge environments frequently encounter intermittent connectivity, leading to a potential data loss and disruption of data continuity. The Azure Monitor pipeline at edge allows you to cache logs during periods of intermittent connectivity. When connectivity is reestablished, your data is synchronized with Azure Monitor, preventing data loss. Finally, observing resources in isolated environments. In the manufacturing sector, resources are often located in isolated network zones without direct cloud connectivity, posing challenges for telemetry collection. With the Azure Monitor pipeline at edge, combined with Azure IT layered network management, you can facilitate a connection between Azure and Kubernetes clusters in isolated environments, deploy the Azure Monitor pipeline at edge, collect data from resources in segmented networks, and finally route it to Azure Monitor for comprehensive observability. Let's dissect the edge pipeline component here. First of all, you will require a data collection endpoint to connect to the cloud pipeline and a data collection rule to define the incoming stream and destination. You can choose to use existing ones as well. Setup of the edge pipeline is super simple. You need to Arc enable a Kubernetes cluster that is on your edge, hybrid, or other cloud environment. You can install the edge pipeline extension as an Arc cluster extension. Once that is done, you can create a pipeline instance to configure it. The edge pipeline instance configuration includes defining the ports at which you want to receive data, destination and stream information, and a cache configuration which is completely optional. Once the instance is successfully deployed, you can set up your on-prem resources to emit the telemetry to the ports configured in the pipeline instance, and then route it to Azure Monitor for observability. If you're using Azure Portal, setting it up is like a breeze. So let's see a quick demo. Before getting started, you need to have an Arc-enabled Kubernetes cluster in your environment and ensure that the required resource providers are registered to your subscription. If you are using the Azure Portal, all the required resources that we previously discussed will be created as part of the deployment. Once you Arc-enable a cluster, go to the extension section. Here, select Add, select Azure Monitor Pipeline extension from the list and click Create. The experience will create an Azure Monitor Pipeline instance. So enter all the essential details. If you are creating it from the context of the Arc Kubernetes cluster, then this section will be pre-filled. We will create a default custom location during deployment. But if you have an existing custom location that you want to use for the extension, you can select that from the drop-down menu. The next step is to create data flows. We will create the data flows by default to receive OTLP and sys logs and send them to a custom table in the Log Analytics workspace. You can also modify the flow. For instance, you may want to receive the logs at a different port here, or you may want to send the logs to a different Log Analytics workspace. If there is no workspace, we will create a default Log Analytics workspace and a custom table for you. The next step is tags. This is completely optional. After this, select Review and Create to check whether all the validations have passed. Once the deployment starts, the Azure Monitor pipeline instance will be installed on your cluster. A default data collection endpoint and data collection rule will be created. The edge pipeline instance will be configured based on the data flow inputs, and you are all set. So now that the instance is created, this is how the Azure Monitor pipeline instance will show up in the Azure portal. After this, you can configure your clients to emit logs to this pipeline instance, and the data will start flowing in the Log Analytics workspace of your choice. Now let's talk about Open Telemetry. Our goal is to make Azure the most observable cloud. To that end, we are refactoring Azure's native observability platform to be based on Open Telemetry, an industry standard for instrumenting applications and transmitting telemetry. In this section, we'll be talking about 1. Azure Monitor's Open Telemetry distro, 2. overview of the Open Telemetry Azure roadmap. 3. Live metrics via Azure Monitor Open Telemetry distro. And finally, cost optimization techniques. To understand our vision on Open Telemetry, let's start with a demo of the Azure Monitor Open Telemetry distro to touch and feel one of the key Open Telemetry offerings we have. The distro is built on top of Open Telemetry SDKs of 4 languages: .NET, Java, Node.js, and Python. It eases enablement of Open Telemetry data collection to as simple as a single line of code. On screen, you can see 4 different VS Code instances with demo apps of those 4 languages respectively. Each of them is doing the same thing. 1. Initializing a sample app either from a bare bones web app or from one of our sample repos. 2. Importing the required libraries for our distro. 3. Adding the code to enable the distro. 4. Customizing the service name to identify itself in the Application Insights App Map tool. And 5. Setting Application Insights connection strings so that the apps can send data to Application Insights instances on the Azure cloud. Now that all 4 apps are running in VS Code, you can see data being connected. Application Insights, with its distributed tracing, triage, and diagnostic experiences, as well as live metrics, will just light up. The Azure Monitor Open Telemetry distro includes the basic capabilities from the Open Telemetry package: logs, metrics, and traces. It is designed and tested to ensure enterprise readiness and a first-class experience on Azure. It also includes Azure-specific capabilities not available in Open Telemetry, such as a reduced enablement effort being supported by Microsoft, as well as Azure-specific features such as Microsoft Enter Authentication, Application Insights Standard Metrics, offline storage, and more. This diagram will demonstrate our offerings and vision on Open Telemetry at a high level. First, at the programming language layer, we have made Open Telemetry APIs part of the .NET runtime. And we have introduced .NET Aspire, an opinionated cloud-native stack with Open Telemetry to further make customer applications more observable. Secondly, at the instrumentation layer, as you've seen from the previous demo, the Azure Monitor Open Telemetry distro supports 4 languages and will eventually replace the classic Application Insights SDKs. To further ease the onboarding experiences for the distro on AKS, we will enable auto-instrumentation with simple steps to automatically inject the distro without the need for the developers to touch any code of their applications running on AKS. Shortly after that, Azure serverless platforms like App Services and Azure Functions will follow. Most Azure customers' applications depend on various Azure offerings like storage, databases, and more. Relatedly, they use their SDKs. We have instrumented every Azure SDK with the Open Telemetry API. The signal from Azure SDKs will be collected by the distro and sent to Azure Monitor so that Azure customers will have complete end-to-end telemetry data. Lastly, at the data collection layer, the distro eases data collection by taking care of communication between the application and Azure Monitor. But the distro only supports 4 languages, and there are customer applications that were already instrumented with Open Telemetry SDKs. For those scenarios, we have begun the work to enable OTLP collection. By early 2025, we will enable Azure Monitor OTLP collection with the Azure Monitor agent, which is owned and supported by Microsoft. By late 2025, we will enable direct OTLP ingestion to support customers who cannot or do not want to install a Microsoft agent along with their applications. This setup may optionally also include an Open Telemetry collector. The applications instrumented with Open Telemetry SDKs can also pick up Open Telemetry signals from Azure SDKs, thus allowing end-to-end telemetry on Azure Monitor. And thanks to the openness of the OTLP protocol, those apps will be able to send OTLP data to other destinations too. Azure Compute Platforms will also make the OTLP path simpler for customers. Azure Kubernetes Service will host and manage the Azure Monitor agent and offer native OTLP endpoints. Azure Container Apps will host and manage the community-owned OTel collector for customers. Azure Functions will instrument the host with Open Telemetry. Lastly, for edge scenarios, the Azure Monitor pipeline provides OTel collector capabilities and can route OTel data to Azure Monitor or Azure Data Explorer or Microsoft Fabric as supported destinations. It can also be deployed as a remote OTLP endpoint. In June, we plan to release live metrics in the Azure Monitor Open Telemetry distro for .NET, Node.js, and for the first time ever, Python will have live metrics too. This is an Azure Monitor specific feature not available in the Open Telemetry community. It is unique to Azure. This capability exports telemetry in near real time, reaching Azure via a high-velocity pipeline. You can see the changes to your application immediately as they hit production. Not only can you see standard metrics like requests and failure rates, but you can also see a stream of every event collected by Azure Monitor. And because these events are pre-sampling, you can see everything. To learn more about how to onboard to Azure Monitor Open Telemetry distro, check out our documentation or scan the QR code. As customers have become more cost conscious, we have heard from a growing number of customers who loved Azure Monitor's consumption-based pricing, but wanted to be able to further tune their cost to only collect and store the telemetry they need. We continue to develop new capabilities that help customers only pay for what they use. The Azure Monitor Open Telemetry distro includes several capabilities to help manage costs. Joe Bierning, a principal engineer at Willow, a global technology company, reached out to us in October of last year, looking to optimize costs. After analyzing the telemetry events that were driving the majority of their costs, we were able to work together to reduce Willow's costs by over 90%. To achieve this, we used a variety of techniques. We disabled the .NET console provider, configured iLogger to only send logs with a higher logging level, and filtered out health checks from an option available in the instrumentation libraries. Together, these set up Willow for success as they scale. Beyond these techniques, the distro also includes fixed lake sampling across traces and logs, and the ability to filter out other attributes with the span processor. Together, these techniques help you only collect what you need and take full advantage of Azure Monitor's consumption-based pricing. On the service side, there is a whole other suite of tools built into the Azure Monitor service. Our default logging tier, Analytics Logs, powers alerting and dashboards. Though for less used logs like diagnostic logs, you could consider switching to the basic logs tier. At ingestion, data collection transformations is available to filter out data on the fly before it reaches storage. It has a cost that is a small fraction of the normal ingestion charge. Other techniques include daily ingestion caps or ingestion sampling available in Application Insights. And as your usage grows, you can reduce your per gigabyte ingestion charge by utilizing commitment tiers. And we're not done. We continue to develop ways to help you further optimize your cloud spend on Azure Monitor. To learn more, check out the blog.